hello again. I'm going to be doing a truth tree this time, and I'm going to be doing an example from again chapter 3, because in the exercises for the truth tree chapter, it just says go back and do all the exercises in chapter 3, except with a tree instead of a truth table. And that's a little annoying because I already did what I thought were the sort of gnarliest 2 exercises from chapter 3, and I don't want to tackle them again. That would be boring for you guys. And this argument only has 2 atoms, so it won't really give you a feel for how truth trees increase efficiency, but we'll do it anyway. So let's look at let's atomize the propositions. First of all, we'll translate these arguments. So we'll say that you're thinking of orange juice as P, and you're thinking of orange blossom is Q, and that's all. So for the next bit, we have to translate it. So if P and not Q is the first sentence, you're thinking of orange juice, but you're not thinking of orange blossom, then therefore, that's P implies Q. So these are our two premises. P and not Q implies not P. Therefore, these are our premise and our conclusion. P and not Q implies not P. Therefore, P implies Q. And this exercise is kind of funny because it really shows the inanity of the claims that they make in advertising. But let's just do the first thing that we need to do for a truth tree and negate the conclusion. And then we can go through the tree and apply linear rules before branching rules, and see if we end up with a valid argument. So we're using linear rules before branching rules, so we want to look for conjunctions and double negations and negated disjunctions and negated conditionals. So we see right away, actually, that we have a negated conditional. So let's do that first. We'll have to do P and not Q will be true in this row. In this branch, I should say. And then we have a conditional up here, and that's a branching rule. So it's a straight up conditional, and we have to have not A and B as the branches. So we'll do don't like that. We'll do it is not the case that P and not Q, and it is the case that not that's our regular conditional rules. And we can immediately see that this branch leads to a contradiction. So it's closed. We write an X under it. So, and then we can actually look up and see if it's not the case that P and not Q, then this one is invalid too. So if you don't immediately see why, then we can just apply our truth trees for our tree rules for a negated conjunction, which is another branching rule. We would say that if not A and B, then it would have to be not P and not Q. And we obviously know that the rule for double negation is that you just make it positive. So then if you look up this row, or this branch, keep doing truth trees again, we've already stated that for this argument, P is true. And we've already stated that not Q is true. So in this branch, not P is true, we have to close it off. And in this branch, not Q is not true, so we have to close it off. So what that means is that this argument, this invalid version that we've created, this negated version that we've created, is not valid. Which means that the original one, where we did not negate the conclusion, where we did not negate the conclusion, is actually valid. This argument is valid because there's no case where the premise is true while the conclusion